cleaning parts. Is it clean?
It's clean.
All right. Where'd my mic go? Everybody wants to know how you clean parts. Like this. Clean. We gotta see if it's oversized or undersized. Don't worry about that junk bike right there. We're not worrying about that. You keep cleaning. You gonna trip me with that line?
Try not to.
It's blocking my way. I can't see what I'm doing around here. We gotta find out if this is oversized or not. Plug. I'm gonna measure it. Okay, 625 is standard. It's 5/8. And this one is 675. Yes, this is an oversized plug. That's why the hole's all screwed up. It's jammed in sideways. Okay, let's see if these lifters are worn out. Nope. If they're between 5 and 6 on the mic, they're good. Looks like it's 705. The other thing I do is make sure the rollers are good and free. On the face, it rolls on the case. It appears you got good lifters. That's a $400 savings. Or more, depending on where you buy them. Could be less too if you buy cheap ones. See, as to where this motor did not have its oil change ever in its life, I don't think. Was all full of muck all through here on the inside of these things. That's all through here. See that? So I got muck on that one. Muck in there. Yeah. Someone did a lousy job of cleaning that flywheel. It's got muck all over it. I don't know who that could have been. See all the gray shit down in there?
Yeah.
See how it's packed in there?
Pause pusher again.
So, someone did a lousy job. Now they got to be blasted and get all that stuff off of them. That's why I blast flywheels when they're all dirty, just to get all the crap off of them. Alright, the shaft is a little worn on the circuit breaker, but it feels okay, so we're good. The Andrews J cam looks okay, but the problem is it's a J cam, that's its problem. So, J cams suck. They run really hot. Hot and lazy. Not a good combination for a Harley. The stock H cam, I have a lot of customers like it better than a J cam. I used to put them in there, and the bikes always ran hot. So I always put the A cams in there so they run better. So, this is a B motor. Instead of an A motor, it's a B motor. Make you feel better?
Sure.
Got a second job. You get the A class. It looks okay. Don't know how round it is, but as much muck has been run through this motor, I think we're just going to rebearing it anyway. The surfaces are good, so they have a lot of metal in there, even though there's a lot of fine metal in all the cleaning. So overall, they look too good. All of the stuff it was replaced when they did it last, so it doesn't look like it's a ton of miles on it. Just they never clean the oil. I would have put new oil, at least change oil once in its life, so I don't think they ever cleaned it. But oh well. Let me see the rods. Yeah, they're not even broken all the way across everywhere yet. Yeah, more or less. Yeah, they're broken all the way across. Ooh. Camera, see, I'm looking at it, not the camera. Camera should be focusing in on that, not the damn junk below. Looks alright. Throw a wrist pin there, see how loose they are. They're fairly tight.
A little bit of movement. But
that's fine. It's like new. Oh yeah. See, it rattles this way, but not this way. That's fine. Just broken in. Rehone them, make sure they're round. We gotta go through them on the machine to see how round they are, but size them. So, now the cam cover, it's an aftermarket cam cover. It's got a restricted breather in here. They put a needle bearing in there, which is overrated. I got an HH in here, which Harley never used. And then it's got Allen bolts in here, so we know it's been not Harley. Because Harley had taper head screws, and these have not been converted. It's always been Allen's. So this is definitely an aftermarket cover. It does not have the dump hole in the back here to let the oil flow out when it gets stuck behind the bushing, because this is set up for end oiler. You can see how there's no hole in the side of the bushing right there for side oiling. Mm-hmm. So this is an end oiler shaft. I used to do this all the time on bikes too, but then I found out you have no oil pressure when you do that. Took me a few years to figure that out though. So the shaft looks okay. So this has an oil hole restrictor in here. Looks like it's about a 60 thou at least. And it does have the side oiler hole in it also. See the hole? Mm-hmm. But it wasn't being used. So what happens on these early motors, which is anything before 470 for sure, maybe as much as 72 and earlier. Harley had one oil system. Oh, that's nice and loose. See, that is loose. So what happens is They got one feed hole for the whole motor. That hole right there. It feeds everything. That's it. Doesn't separate the top and the bottom. So the whole motor gets pressurized equally, and the top end, oil has to go way uphill through all the lines and through up the cylinders to these little narrow holes, and it sucks up a lot of pressure. So it doesn't like going uphill. It likes going into the crank. So the crank starves the top end for oil. Harley, they had it restricted by only having that hole line up once every 320 degrees or so. Then you had about a 60 or 80 degree of overlap between the two holes, which really only flowed real good for a few degrees. And then it shut it off. So it couldn't suck all the oil out of the motor. When you go to an end oiler, it sucks all the oil out. The other thing that happens is there's a centrifuge. So the oil goes in the center, comes out the top through the crank pin, and you multiply that by RPM, so that makes a hell of a suction. It just slings the oil out, and it siphons the oil out, so it actually sucks all the oil that pump will make. You can actually have this fitting out while the bike is running at low RPM, and there'll be no oil flowing to the top end. It won't even fill up this hole. You can actually look down there with a flashlight and see the oil going past, because the crank's taking everything it can make.
Wow.
Especially in this early pump, which is really small. I was having this problem on aftermarket aluminum pumps. We weren't getting any oil pressure. Yeah, even a high volume pump.
Right.
At idle, at a dead idle, you got no flow. At about 13 to 15 RPM, it would overcome what the crank was taking, and would start flowing uphill. Not a lot of pressure, just flowing. When you got it to about 2,000, 2,300 RPM, that's pressure just spike up instantly to 40 pounds plus, because now the high volume pump is working and it's overcoming everything. But on a standard volume pump, or these old iron pumps, you don't have that kind of volume, so you pretty much got no pressure all the time. So that's the problem with these systems. So if you're going to do this and you're going to do an end oiler, you better make sure the hole in this crank is probably like 45 thou or less. So it's not taking everything that this motor will make. And even then, that'll kill the pressure at idle, I'm sure. Depends on how big the pump is. So that's how you do it. So you either let the crank be a side oil like it should be, or you have to restrict the hell out of it. Like I said, it's got to be really small, like 40, 45 thou. Like I said, that's on an aftermarket aluminum pump, not these old iron pumps. Especially the early iron pump like that one, which has really got small gears. So that's what the big deal is on that is. So if you're going to use this cover, you need to do that. Now what Harley did was, so that oil wouldn't get behind the bushing and push the bushing out, they had a hole in here. So if there's any oil that went past, that went to the inside, it would just dump out right here. So if you're going to do a side oiler motor, you can plug this hole or just leave it. Me, I wouldn't worry about it. Harley don't make enough pressure to make that bushing come out when it's pinned in there. So I think that was a dream of Harley engineering back in the 30s when they designed that system. So we're going to do something about the oil supply. Like I said, we're going to have to restrict this way on down. We're definitely going to go to the 55 and later pump, which is a bigger pump anyway. The other option is just to go to an aluminum pump and get rid of that completely. But that's a lot. Then you gotta go in and rechange all these galleries and do a bunch of work, so then you lose the look of an iron pump. So I would say if you're gonna stay with an iron pump, go to a side oiler only. Pull this bushing out, put the correct bushing in there, we're good. And plug up the hole in the end of the crank. And you're good. Otherwise, if you want to use the end oiler, we'll restrict that thing down to about 40 thou, 45 thou, something like that. And if you had an aluminum pump, you might be able to tolerate that, but with an iron pump, I just don't think you get enough pressure. We are going to spin the pump faster by putting the gears in it. So what gears do they have in it? That looks like a 25. Where's the small one? Oh, does it? Oh, here. It's 5 or 6 tooths. How many tooths can you see? Can you count teeth quick? If you count from the side, it's easier.
5.
5. Okay, well 5 is stock. So in 73, Harley went to a higher volume pump. You know what they did? They changed the gear ratio. They went to a 6-tooth here and a 24 here instead of a 5 and a 25. So they sped the pump up faster. That's how they got more volume. They didn't do anything about the gears. The pump's the same. They sold you a pump, but the gears, only was changed, the drive gears. So one thing we can do, we can put the faster drive gear ratio in it, which will make the pump put out more volume and pressure. We tighten up the bushing in here so it's nice and snug. We tighten up the gear space inside the pump so it's real tight. So they have low blow by on the inside of the pump. And that's about all you can do. Tighten up everything you can tighten up. And I should go back to a side oiler design and eliminate this end oiler. That'd be the other thing. Alright, so that's where we're at on this project for now. I gotta go measure the rods and see if there's how round they are, but I'm gonna redo them anyway, so it doesn't really matter. But overall, the motor looks fairly good. I would throw that cam onto eBay or Chopper Swapper or someplace and get rid of it and put a real cam in it. The lifters are okay. You're solid lifters, so we go to an A grind, run solids on it, you'd be fine. If you want to do hydraulics, then good luck. Those stupid ass Harley hydraulics suck. Then if you want to do that, I go to the Evo style conversion kit S&S has for shovel heads. And we stick it aside this motor because they don't know the difference. You get the cam that S&S makes for the shovel head generator motor. Stick that in there. And then we got to make custom push rods for the panhead. Because they have a, Harley has like a 1/2 inch ball on top and a 3/8 on the bottom. Shovel has a 3/8 or 5/16 on both ends. I forget what it is, but anyway. Panhead has that big ball on top. That's why they don't make the kit for panhead. They don't make the push rods. But the push rods can be made. It's no big deal. But that's an expensive way of doing it. You can also put the aluminum oil pump on it and do that and upgrade all that stuff. It's all stuff that upgrades. But for a bike that looks stock, that we're trying to make something look like this piece of crap here, something this style, I'm assuming that's what you're doing. So then we'll keep the old parts on and make it look better. Still think you need to get rid of these stupid ugly blocks. See, maybe you can steal his blocks right there. He's got a set. Oh, his are aftermarket too. Yeah, he's got crappy ones too. And these things all got crap. All right, well that's where we're at on this. We got some decisions to make.